Now in the last example 6, I want to find the perimeter in the area of this pentagon. Now notice, I never gave you a formula for the pentagon. So we're going to have to kind of devise our own formula in this problem. First off, let's start with the perimeter. To find the perimeter, I need to find the length of each side. Well, the nice thing, C to D I can count. So I'm going 1, 2, 3, 4, 5, 6. So C to D is 6. I can do the same thing from D to E. I'm going to go 1, 2, 3, 4, 5. So that distance is 5. I can't do that with A to E or A to B or B to C. So here's what I'm going to do. I'm going to write in my ordered pairs. So A is at 0 and 1, 2, 3, 4. So I know A is at 0, 4. E is at negative 1, 2, 3. So negative 3 and up 1. And B is over 1, 2, 3, 4. B is at 4, 0. And then C is at 3 and negative 1, 2, 3, 4. Now what I'm going to do is I'm going to find the distance for A to E. So I'm going to use my distance formula. See how that shows up again? So my distance from A to E, I'm going to say that's going to be 4 minus 1 squared plus 0 minus, not a comma, minus a negative 3 squared. So 4 minus 1 is 3. 0 plus 3 is also 3. So in other words, it's a square root of 9 plus 9, which is 18. But I'm going to take the square root of that answer, and then I think I'll round it to the nearest tenth. It doesn't tell me what to round it to, but I think that's what I'll go with. So the square root of 18 is going to be about 4.2 is the length of A to E. Now, let's turn around and let's do A to B. So now I'm going to do A to B. So I'm going to subtract my x's. So I'm going to go, oh, this one turns out pretty nice. It's 4 minus 0 squared plus 0 minus 4 squared. So in other words, it's 4 squared plus negative 4 squared. So that's the square root of 16 plus 16, which is the square root of 32. And then use my calculator, and I'll take the square root of 32, and I'm going to say that's about 5.7 if I round it. Now let's find the distance from B to C. Got to do a lot of work on this problem, don't you? So if I look at the distance from B to C, I'm going to say that is going to be, subtract my x's, so I'm going to say 3 minus 4 squared plus negative 4 minus 0 squared. Well, let's simplify that. 3 minus a negative 4, that's not a negative, though, from B to C. It's just 3 minus 4. Sorry about that. I put a negative in there by accident. It was just 3 minus 4. So 3 minus 4 is 1, or negative 1. So it'll be the square root of negative 1 squared plus negative 4 squared. Well, that will be the square root of 1 plus 16, which is the square root of 17. So use your calculator, find the square root of 17 on your calculator, and you get 4.1. And so we know this distance is 4.1. So in other words, to find the perimeter of this pentagon, we're going to add up all the sides. So I'm going to start with 4.2. So I'll say 4.2 plus my next one is 5.7 plus 4.1 plus 6 plus 5. And now we're just going to add them all up. So if I go 4.2 plus 5.7 plus 4.1 plus 6.5, my perimeter turns out to be about, and each of these are rounded, so it's about 20.5. Now notice, I never gave you any units on this problem. It's just on the coordinate grid. So you don't have to include units on there. Now we've got to find the area. Well, to find the area, we need to split this shape up into things I know how to find the area of. I'm going to, now we can do this a couple different ways. I could split this shape into some shapes I could find the area of. Now, one way to do that is to split it on the inside. So, for example, here would be a triangle. And then I've got another triangle going down. And then we've got this rectangle. So I got 3 parts I could find there. That's one way to do it. The other way to do it, and I think that's the way we will do it, but the other way to do it is, rather than looking as through a lens of addition, I'll look at through a lens of subtraction. I could draw a rectangle that encloses my polygon, encloses my pentagon here. So I'm going to draw this rectangle that goes all the way around. And so then what I'm going to do is I'm going to find the area of my square, or in this case rectangle. I'm going to subtract off the 3 triangles, and then I have what's left over. But I think it's easier to add on this one. So we're going to do it by adding. So first off, we're going to find the area of the triangle up top. Now I know the area of a triangle is 1/2 base times height. Now I'm going to go back here. I'm going to find the base and the height. Remember, base and height are at 90-degree angles from each other. So my base, I'm just going to count across here. My orange is going to be my base for my top triangle. So I'm going to say 1, 2, 3, 4, 5, 6. So my base is 6. My height, let's draw on the height. So the height goes from my vertex to my side. So here's my height right here. And that I'm going to count also. So that'll be 1, 2, 3. So I'm going to take 1/2 times 6 times 3 for my top triangle. So 1/2 times 6 times 3. 6 times 3 is 18. Half of 18 is 9. So I know the area of my top triangle is 9. Now let's find the area of my rectangle. So look at the area of the rectangle. It's 1, 2, 3. Well, we know it's 6, right? We already counted that part. Let's count the height. 1, 2, 3, 4, 5. So it's 6 by 5. So I know this area is 30. We've got this little triangle here on the side with the base of 5 and my height of 1. So then to find the area of my little triangle, I'm going to say, this would be the small triangle, 1/2 times base times height, which is 1/2 times 5 times 1, which would be 5/2, or 2.5. Now to find the total area, we're going to add them all up. So I'm going to say 9 plus 30 plus 2.5. So 30 plus 9 is 39, plus 2.5 is 41.5. And there's the area of that pentagon. So that was a little bit harder one, or a little bit longer one to do, wasn't it?